Mastering microservices design patterns. Microservices architects must prioritize reliability, maintainability, and efficiency to avoid catastrophic failure. How do its designers achieve operational excellence in a microservices architecture, and what are its essential principles to ensure reliability, maintainability, and efficiency in its operations? Achieving operational excellence in a microservices architecture involves a deliberate and systematic approach to designing, deploying, and managing microservices to ensure reliability, maintainability, and efficiency in their operations. This requires a deep understanding of the unique challenges and opportunities inherent in microservices architecture and the adoption of specific principles, practices, and patterns to overcome them. Design for observability. To achieve operational excellence, microservices must be designed for observability, which means that they should provide clear and concise insights into their internal workings, performance, and health. This is critical because microservices are highly distributed, and it can be challenging to understand how they interact with each other and with the overall system. Designing for observability involves 1. Instrumentation, implementing logging, metrics, and tracing mechanisms to collect data on the performance, latency, and errors of individual microservices and their interactions. 2. Monitoring, setting up monitoring tools and dashboards to visualize and analyze the collected data, enabling real-time insights into system behavior. 3. Analytics, applying data analytics and machine learning techniques to identify patterns, trends, and anomalies in the system's behavior, allowing for proactive decision-making. Implement automation. Automation is essential for achieving operational excellence in microservices architecture. Automation enables rapid and reliable deployment, scaling, and management of microservices, reducing the likelihood of human error and increasing efficiency. Implementing automation involves 1. Infrastructure as code, IAC, defining and managing infrastructure configuration through code, allowing for version control, reuse, and automation of infrastructure provisioning. 2. Continuous integration and continuous deployment, C/CD, automating the build, test, and deployment of microservices through pipelines, ensuring consistent and reliable delivery. 3. Automated rollbacks, implementing automated rollback mechanisms to quickly revert to a previous version of a microservice in case of a failure or error. Ensure loose coupling. Loose coupling is a fundamental principle of microservices architecture, and it is essential for achieving operational excellence. Loose coupling enables individual microservices to evolve independently, reducing the risk of cascading failures and making it easier to maintain and update the system. Ensuring loose coupling involves 1. API-first design, designing APIs that are independent of specific microservice implementations, allowing for flexibility and decoupling. 2. Message-based communication, implementing message-based communication between microservices, enabling asynchronous and decoupled interactions. 3. Domain-driven design, organizing microservices around business domains, rather than technical layers, to ensure alignment with business capabilities and reduced coupling. Foster a culture of continuous learning. Achieving operational excellence in a microservices architecture requires a culture of continuous learning and improvement. This involves 1. Blameless post-mortem analysis, conducting retrospective analyses of failures and errors to identify root causes and implement corrective actions. 2. Experimentation and feedback, encouraging experimentation and feedback mechanisms to drive continuous improvement and learning. 3. Cross-functional collaboration, fostering collaboration between development, operations, and quality assurance teams to share knowledge and expertise. Emphasize security and compliance. Operational excellence in microservices architecture requires a strong emphasis on security and compliance. This involves 1. Security by design, incorporating security considerations into the design of individual microservices and the overall system. 2. Compliance automation, automating compliance checks and reporting to ensure adherence to regulatory requirements. 3. Identity and access management, implementing robust identity and access management mechanisms to control access to microservices and data. By adopting these principles, practices, and patterns, organizations can achieve operational excellence in their microservices architecture, ensuring reliability, maintainability, and efficiency in their operations. This enables them to deliver high-quality services to their customers, respond quickly to changing market conditions, and drive business success.